There's a tiny patch of sky that appears completely empty when viewed from Earth. No bright stars, no glowing nebulae, no obvious galaxies, just darkness. Yet years ago, the Hubble Space Telescope stared into that darkness and transformed astronomy forever. What seemed like an empty region of space turned out to be anything but empty. It was packed with thousands of galaxies, each containing billions of stars and stretching back across cosmic time. For many people, the Hubble Deep Fields became one of the most profound images ever captured. They served as a reminder that even the darkest part of the night sky is filled with worlds, galaxies, history, and ancient light too faint for the human eye to see. But now, the James Webb Space Telescope has returned to that legendary region, and what it discovered makes Hubble's famous image seem almost unfinished. After nearly 100 hours of observing the same tiny patch of space, Webb revealed galaxies that Hubble simply could not detect. Faint objects emerged from the darkness, red galaxies hidden in infrared light became visible, and previously unseen structures appeared that may help astronomers understand how galaxies formed and evolved over billions of years. This was not just another deep space image. It was a second look through one of the universe's most famous windows. And the longer Webb stared, the more the darkness itself seemed to dissipate. The Hubble Ultra-Deep Field remains one of the most important images in the history of astronomy. Released in 2004, it was created from more than 11 days of continuous Hubble observations focused on a single, tiny region of the sky. Later, the Hubble Extreme Deep Field pushed even further by combining years of observations from nearly the same location. The idea behind both images was remarkably simple. Point a telescope at what appears to be nothing, wait patiently, collect every possible photon of light, and see what emerges. What Hubble found stunned the scientific world. The darkness was filled with galaxies, not dozens, not hundreds, but thousands. Spiral galaxies, elliptical galaxies, tiny reddish smudges, distorted structures, and ancient light from a universe far younger than the one we see today all appeared within that seemingly empty patch of sky. It was as though someone had drilled a tiny hole through the night and discovered an entirely different universe hidden behind it. What makes the deep field so extraordinary is its incredibly small size. The Hubble Extreme Deep Field covers a region of the sky far smaller than the apparent diameter of the full moon. If you held a tiny grain of sand at arm's length, it would roughly cover the same area. Yet within that microscopic patch of sky, Hubble detected nearly 10,000 objects, almost every one of them a galaxy. The message was unmistakable. The universe is not merely vast, it is saturated with structure. Wherever we look deeply enough, galaxies are waiting to be found. Despite its incredible achievements, Hubble had its limits. It observed visible and near-infrared light with extraordinary clarity, but many of the oldest, dustiest, reddest, and most distant galaxies remained beyond its reach. Their light had been stretched by the expansion of the universe into longer infrared wavelengths. Their stars were hidden behind thick clouds of dust, and their signals were simply too faint and too red for Hubble to fully reveal. The question remained, what was still hiding in the darkness? When Webb finally looked, the answer was astonishing. The James Webb Space Telescope did not simply repeat Hubble's observations. It explored the same region with an entirely different kind of vision. Webb was designed around infrared astronomy, allowing it to see through cosmic dust and detect light that has been stretched into infrared wavelengths by the expansion of space. This makes it exceptionally powerful for studying the earliest and most distant galaxies, whose light has traveled for billions of years before reaching us. For this new view, Webb relied on two of its advanced scientific instruments. MIRI, the mid-infrared instrument, observed the field at mid-infrared wavelengths, while NIRCam, the near-infrared camera, simultaneously collected high-resolution near-infrared data. Together, these instruments produced a view of the region that Hubble could never fully achieve. The observations themselves were extraordinary. Webb spent nearly 100 hours focused on this single patch of sky, the longest continuous observation the telescope had devoted to one region at the time. In deep-field astronomy, patience is everything. The longer a telescope observes, the more ancient and incredibly faint light it can collect. Galaxies that would remain invisible in shorter exposures slowly emerge from the darkness as more photons accumulate. When Webb's image was compared directly with Hubble's famous view, the difference was immediate. Regions that appeared completely dark in Hubble's image suddenly contained galaxies. Objects that had barely been detectable became brighter and more detailed. Structures that once appeared uncertain came into sharp focus, and the background itself seemed far less empty than before. Most remarkably, Webb revealed at least 2,000 additional objects that Hubble had never detected. That is perhaps the most astonishing discovery. Hubble had already made this tiny region of the sky seem unimaginably crowded, yet Webb showed that it was even more densely populated than anyone had imagined. Part of the reason lies in Webb's sheer size. Hubble's primary mirror measures 2.4 meters across, while Webb's enormous segmented mirror spans 6.5 meters, giving it a light-collecting area roughly 6 times larger. As a result, Webb gathers vastly more photons in the same amount of time. Faint galaxies become visible more quickly, dim objects appear brighter, and fine details emerge where Hubble could see only shadows. But Webb's greatest advantage is not simply its larger mirror. It is its ability to observe the universe in infrared light. Many galaxies are not invisible merely because they are extremely distant. They are hidden because the expansion of the universe has stretched their light into wavelengths that Hubble was never designed to detect. Others remain concealed behind thick clouds of cosmic dust, where intense bursts of star formation occur inside heavily obscured, reddish galaxies.